Have you ever wondered how time and space intertwine in the vast universe? It's a fascinating thought, isn't it? Let's start by considering time and space as two separate entities. Time, as we know it, is a measure of events. It's a ticking clock, the turning of pages, the change of seasons. It's a ceaseless river, flowing from the past through the present and into the future. On the other hand, space is the measure of distance and positions. It's the vast emptiness between celestial bodies, the distance between you and your screen, the length, width, and height of everything around you. Now, these two concepts, time and space, though seemingly unrelated, are in fact deeply intertwined in the fabric of our universe. They are not individual dancers performing their own steps, but partners moving in rhythm to the music of the cosmos. So, you may ask, how exactly do time and space link together in this cosmic dance? The relationship between time and space is not as straightforward as it may seem. Delving into the intricacies of this relationship, we stumble upon the theory of relativity, a revolutionary idea proposed by Albert Einstein in the early 20th century. This theory fundamentally changed our understanding of the universe, merging the concepts of time and space into a single entity, a four-dimensional fabric known as space-time. Imagine space-time as a trampoline. When an object, say a bowling ball, is placed on it, the trampoline bends under its weight. Similarly, objects with mass cause the space-time fabric to curve, to warp. This curvature, this bending, is what we perceive as gravity. So in essence, when we feel the pull of gravity, we're actually experiencing the curvature of space-time caused by mass. Now let's take this a step further. The theory of relativity also tells us that time doesn't tick away at the same rate everywhere. It slows down near massive objects. This phenomenon is known as time dilation. Picture a clock near a massive star. That clock would run slower compared to a similar clock far away from the star. This isn't because the clock is broken or the star has some mystical powers. It's because the space-time fabric is more curved near the star, and so time ticks slower. So you see, time and space dance together in this cosmic ballet, each influencing the other, each shaping the other. They are not separate entities, but two sides of the same coin, twirling and spinning in a dance choreographed by the laws of physics. This dance is not just an abstract concept, it's a fundamental aspect of our universe. It governs the motion of planets around stars, the formation of galaxies, and even the expansion of the universe itself. It's a dance that's been going on for billions of years and will continue for billions more. Therefore, time and space, as we understand it, are mere threads in the grand cosmic tapestry. To summarize this celestial conundrum, let's take a moment to revisit the key ideas we've explored today. We've delved into time not merely as ticking seconds on a clock, but as a measure of events, a grand symphony of occurrences that shape our universe. We've also journeyed through space, not just as a vast expanse, but as a measure of distance and positions, a canvas upon which the universe paints its masterpiece. We then ventured into the realm where time and space dance together, bound by the elegant theory of relativity. This dance, this intricate interplay, is the cosmic ballet that shapes our understanding of the universe. Yet, the final note to strike is that our understanding of time and space is still evolving. With each new scientific discovery, we get a little closer to unraveling the mysteries of this cosmic waltz. So next time you check your watch or look up at the stars, remember, you're not just observing time or space, but a fascinating interplay of the two.